Surface chemistry. Surface chemistry deals with the phenomenon which occur at the surface of a substance, like adsorption, corrosion, heterogeneous catalysis. These are the phenomenon where at the surface the process takes place. So first we are covering up adsorption. It's adsorption, AD, the phenomenon of attracting and retaining the molecules of a substance on the surface is called adsorption. Like this substance, this is attracting the molecules from outside. It is attracting these molecules from outside and retaining these molecules here on the surface. Then this phenomenon is known as adsorption. The phenomenon of attracting and retaining the molecules of substance on the surface is called adsorption. The substance adsorbed, these substances which are adsorbed on the surface, these are called adsorbate, and the substance on the surface of which adsorbate are sticking, this substance is known as adsorbent. So we can say adsorbate plus adsorbent is equal to adsorption. So what is required for adsorption? Adsorbate and adsorbent are required. And the reverse process of this, that is removal of these adsorbate particles from the surface of adsorbent, is known as desorption. The reverse process, that is removal of the adsorbate substances from the surface of adsorbent, is called desorption. And if this adsorbent is a metal and it is adsorbing the gas molecules on its surface, then this process is known as occlusion. If the substance is metal and gas molecules are adsorbed on the surface of metal, then this is called occlusion. OCCLUSION. This is the introduction of the chapter. So our next topic, evidence in support of adsorption. Some evidences which will support adsorption phenomenon, like gases like oxygen, hydrogen, ammonia, when they are taken in a closed vessel, when we take these gases in a closed vessel, for example, there is oxygen here in this closed vessel, and in this there is powdered charcoal. Powdered charcoal is added in this. It is observed that the pressure of this gas in enclosed vessel decreases when this charcoal is added, because oxygen gas gets adsorbed on the surface of the charcoal. Since some gas adsorbs here, so this gas is less now in the container. That is why the pressure of the gas will be now less, because free gas molecules will be less now. Second evidence, If we take a solution of some organic dye, its solution when we'll take, like if we take methylene blue, so the blue color here in this, and to this container we add animal charcoal and stir it. It is observed that the intensity of the color in the solution decreases. Initially the color will be dark blue, but after addition of animal charcoal, the intensity of the color in the solution decreases. This shows that some of the methylene blue dye is adsorbed on the surface of animal charcoal. It is adsorbed on the surface of animal charcoal. Next topic, mechanism of adsorption. How adsorption takes place? It takes place because of presence of unbalanced forces on the surface of a substance. Some unbalanced forces are there on the surface of a substance. For example, if we take a container, in this we are taking a liquid. Some liquid is taken in this container. A molecule in the interior, in the bulk of this liquid, is completely surrounded from all sides by other molecules. So, balanced forces are acting on this molecule. But a molecule which is there on the surface of this liquid, this is attracted by the molecules inside the liquid. So, net inward pull is here on this molecule. Because of this, unbalanced forces are acting on this molecule. And because of these unbalanced forces, this molecule will start attracting the molecules from outside on its surface and retain these molecules on its surface. These particles on the surface of liquid attract the particles from outside and retain these particles on its surface. And this phenomenon is known as adsorption. So when unbalanced forces are there on the surface molecules, then only they are attracting the molecules from outside and retaining them there on its surface, and this phenomenon is known as adsorption. So which phenomenon has taken place here? That is adsorption. Next is distinction between adsorption and absorption. Distinction between adsorption and absorption. Adsorption, in this, substance is concentrated only at the surface and does not go in the bulk of the adsorbent. In adsorption, we know substance means adsorbate is concentrated only at the surface and does not go in the bulk of the adsorbent. It does not go inside the adsorbent. Why? Example, when a chalk is dipped in ink, the surface retains the color of the ink. So when a chalk is dipped in ink, the color of ink will come only on the surface of chalk. It does not go inside. So which phenomenon is taking place here? Adsorption. Another example is, if we take silica gel and anhydrous calcium chloride and keep them in a room where there is moisture. In case of silica gel, the moisture will be attracted and is retained only on the surface of silica gel. While in case of anhydrous calcium chloride, moisture goes inside in the bulk and mixes up throughout the interior of calcium chloride. So in case of silica gel, since particles are only on the surface, so this is showing adsorption. While in anhydrous calcium chloride, since the moisture has gone inside the bulk and uniformly mixes inside, so this is an example of adsorption. This is a distinction between adsorption and absorption. Now, if both adsorption and absorption takes place simultaneously, if both the phenomena are taking place simultaneously, then this phenomenon is known as sorption. Then this phenomenon is called sorption. Next topic, types of adsorption. Types of adsorption. There are two types of adsorption. First is physical adsorption, or called physisorption, or van der Waals adsorption. Van der Waals adsorption. Second type is chemical adsorption, or also called chemisorption, or also known as Langmuir adsorption. So adsorptions are of two types, physical adsorption and chemical adsorption. Next topic, characteristics of physisorption. Characteristics of physisorption. Characteristics of physisorption, that is physical adsorption. First characteristic is gas accumulates on the surface of a solid by weak van der Waals forces. If this is a solid that is adsorbent and gas molecules, they accumulate on the surface, and between adsorbent and adsorbent, the forces which are there are weak van der Waals forces. That is why physical adsorption is also known as van der Waals adsorption. Second characteristic is lack of specificity. This means any gas can accumulate on the surface of any adsorbent. So no preference of any particular gas on the surface of adsorbent is there in case of physisorption. No preference of any particular gas. Hence, physisorption lacks specificity. Next characteristic is nature of adsorbate. Physisorption depends on adsorbate, that is, amount of gas adsorbed by a solid depends on the nature of gas. On the surface of this solid adsorbent, how much gas will adsorb? That depends on which gas is there as adsorbate. So amount of gas depends on which gas is here in adsorption. If this gas is easily liquefiable gas, then this gas will adsorb easily on the surface of this adsorbent. And easily liquefiable gases are those which have high critical temperature. That means there are strong forces between the gas and the solid. Next characteristic is reversible nature. Adsorbate plus adsorbent. Adsorption takes place, but this process can be reversed also. Gases are adsorbed on the surface of this solid. If more pressure is put on these gas molecules, more of gas molecules will come near to the solid and will stick to the surface of solid. That is, adsorption will be more. But if pressure will be decreased, then the adsorbate will move away from adsorbate and hence the process will decrease. Next characteristic is surface area of adsorbent. Surface area of adsorbent. Extent of adsorption increases with increase in surface area. Like if we take this adsorbent and now we change this into a powdered form. If we change this to a powdered form, its surface area is more. More is surface area, more adsorbate particles can attach here. Here less number of adsorbate particles will link. Hence, physical adsorption increases with increase in surface area. Next characteristic is enthalpy of adsorption. Enthalpy means energy. Energy in adsorption. It's very low. In physical adsorption, this enthalpy of adsorption is very low, 20 to 40 kilojoules per mole. Now, when gases are linking on the surface of solid, there are unbalanced forces on the surface of adsorbent. That is why this adsorbent is pulling the adsorbate molecules on its surface. So when they link here and stabilize the surface molecules of adsorbent, so energy will be released in this process. And that energy released is very less, approximately 20 to 40 kilojoules per mole, and known as enthalpy of adsorption. Next characteristic of physisorption, the last characteristic of physical adsorption is multimolecular layers. Multimolecular layers form on adsorbent as pressure is increased. In case of physical adsorption, on the surface of adsorbent, it's not that only one layer of adsorbent will form. If we put more pressure here, then more particles will come on the surface of adsorbent. Like this, more particles can come, and hence multi-layer formation can take place. Our next topic is characteristics of chemisorption. After physical adsorption, characteristics of chemisorption. First characteristic is when gas molecules or atoms are held on the surface of a solid, that is adsorbent, by chemical bonds. By chemical bonds, the adsorbent molecules, they are held on surface of adsorbent. Then the adsorption is called chemical adsorption. So this word chemical adsorption is from because a bond is formed between adsorbate and adsorbent, and that bond is a chemical bond. This bond can be ionic or this can be covalent. This bond can be ionic or this bond can be covalent in nature. Since a bond is formed between adsorbate and adsorbate, that is why this is known as chemisorption. Next characteristic is high specificity. High specificity. It will occur only if there is a possibility of a chemical bonding between adsorbate and adsorbent. If between this adsorbent and adsorbate there is a possibility of forming a bond, then only chemisorption will take place. So this is highly specific in nature. It's not that any adsorbate can link to the surface of any adsorbent. Third characteristic, irreversibility. As chemisorption involves a chemical bond formation, so this forms a compound and which is not easy to break. Adsorbate and adsorbent is a bond formed here, and because of which there is formation of compound, and it's not easy to break this bond. That is why normally chemisorption is irreversible in nature. Next characteristic is surface area. Like physisorption, even in chemisorption, with increase in surface area, adsorption increases. Next characteristic is enthalpy of adsorption. When chemisorption is taking place, high amount of energy is released, 80 to 240 kilojoules per mole, because the bond formed is strong between adsorbate and adsorbent. That is why high amount of energy is released in the case of chemisorption. Last characteristic of chemisorption is unimolecular layer formation. Unimolecular layer formation. Since in case of chemisorption, adsorbent is forming a bond with adsorbate. So once the bond is formed, it is stable. So no more adsorbate molecules can link with adsorbent. Hence, unimolecular layer formation takes place in case of chemisorption.